Yes, ma'am. We are live now. Please start.
Working data and machine learning track of ETA in Infosys. First of all, let me thank IIT Madras and NPTEL for giving me the opportunity to talk to all of you. Yeah, so with that, let us start our today's presentation. First, let me share my screen. Is the screen visible?
Yes, ma'am. It is
Balaji,
visible.
can you just... Okay, so let me do a little setup over here. Okay. Okay, so welcome to the session on demystifying artificial intelligence. Yeah, so first let me take you through the topics which I am planning to cover in this session. So, so I have divided this presentation into 4 parts. Why AI? What is the need of AI in business and industry and now? And also we will see the potential of artificial intelligence in industry. And the second part, we will talk about what is AI. I will give you a technical overview of artificial intelligence. We will also discuss about important AI techniques. Also, we will discuss the AI architecture part. Third section, we will talk about the adoption of AI across different domains of business. And at the end, we will look into the sneak peek into popular AI platforms. So that's the agenda for today's presentation. So let us first start with why AI. Okay. So let me motivate you. Let me give you some real applications where AI is used and very important problems are solved using this technology. So let us recall an incident, so few years back in the city Boston. So one marathon event was going on, and suddenly there were few blasts. Many people were injured, and there was chaos in the event. Okay, so what? So after that, what? So after that, it's a challenge for the FBI, the Federal Bureau of Investigation, to to reach to the culprits, to the suspects. But how to do that? There were so many people present in the event. It is indeed difficult. Now, what do you think? What would they have done? So what they did was they asked the spectators, the people who were watching that event, to deposit the photographs and the videos they took in that event. And they collected the videos from surveillance cameras, cell phones. They collected, from cell phone tower, the call logs, the text messages from social media. They collected a lot of information. Okay, and at the end, they collected 10 TB of data. Just notice this: 10 TB, 10 terabytes of data. So that's a huge amount, isn't it? So it is around 10,000 GB, gigabytes. Now, to analyze this amount of data, to get some information about the culprits, will take how much time? So that's the question here. So if we take any conventional technology, if we use any conventional technology to analyze this much amount of data to get some information or to reach out to the suspects, it may take days, weeks, months, maybe years. But it will not help them, isn't it? So once such incident happens, we need to reach to the suspects as soon as possible so that it can avoid such further unpleasant incidents, right? So what FBI did was they did all kinds of investigation, and within 24 hours, they were able to reach the suspects. They were able to find the people who were behind this incident. And this was possible because of all text analytics, image analytics, video analytics. So all these AI technologies they could use, and then they could, find a solution to this problem. So definitely that is a cutting edge technology which helped them to reach to the suspects, find the suspects. So this is one scenario. So let me tell you another scenario where the AI technology has really helped to find a solution. In a hospital in University of Tokyo, one patient was admitted, and the doctors diagnosed the disease in the lady, and then they prescribed medicines, and then the lady was undergoing the treatment. But the bad news was she was not responding to the treatments. What may be a reason for this? Maybe the diagnosis was not proper, isn't it? Otherwise, the disease should respond to the treatment. After that, what happened? So, they fed the symptoms of the disease, the symptoms of the patient, the genetic changes to a machine, and then the machine could successfully, search the symptoms against 20 million cancer research papers. So worldwide, so people are doing research on cancer, and this many research papers it could find, and it could check the symptoms of the patient, with these cancer research papers, and it could find a match, and then they could detect what kind of problem is that, and they started treating the lady according to the disease they found in the paper, and the good thing is that the patient respond to the treatment, right? So can you see that this finding is a lifesaver, and how it is possible? Just think of the number: 20 million cancer research papers. So how many doctors will know about the findings of these very research papers? One doctor, a team of doctors, it may not be possible. But with an AI system, with some kind of natural language processing and other algorithms, the machine or the algorithm would search successfully the symptoms of this patient and the findings of the research paper, and there was a match, and it could save the life. So this is another scenario. Another scenario is, so this is now evident in this pandemic time. So because of this, contact-free transactions, we are more encouraged to, use our card transaction. So that is fine. That is easy for us and for the people also with whom we are doing the transactions. But there is a big challenge over here. There can be fraudulent transactions also. So that's the challenge here. And how many cards? You just think American Express or the Visa cards, right? So if you see that, you have millions, billions of cards, and we are transacting, across the globe. It's not specific to a region. So now, if some fraudulent activity happens, now can you think that it can happen anywhere, anytime, any card? Now, how to identify such theft, such behavior? And again, the answer is artificial intelligence, the techniques of artificial intelligence. And it is done by American Express. So that's a company, and it could save over 1 trillion transactions. So means possible fraudulent transactions, and prevented about $2 billion of potential fraud in a single year. How did they do it? So definitely, any conventional strategy may not help us, see the problem, the data, right, the hugeness. So definitely, you need a cutting-edge technology which can solve such problems. Okay, so this is another problem. The other problem is like Netflix. So all of us know this is the streaming the company, right? So here what we do is, it's critical for Netflix to find customers, so that customers will find the desirable content quickly. And there is a survey which tells that customers tend to give up if it takes longer than 90 seconds to find a show they want. Suppose you come back from your office and you are tired and you want to watch something, and you open your TV, switch your TV, and if you do not see, if you do not see something which you like, then within 90 seconds you tend to change the show, or you may not want to watch after 90 seconds. So within that 90 seconds, it's a challenge for Netflix to bring um, the content which people will like within that time. Okay, so and also, and if you do not get the show which you like, you may not subscribe, and if you do not subscribe, that's a loss for the company. So in order to stop canceling the subscriptions, so Netflix has, they have to give some personalized recommendations which will be suitable for the people who are watching and all. Okay, so that's how they have, um, they have better recommendations. They have better, so search results. They have personalized recommendations because different people have different choice. So now, how to do that? So some recommendation algorithms are needed, right, to do this job. And do you know what is Netflix price? So Netflix price contains around $1 million US. And the price is about, you come up with recommendation algorithms which can beat the accuracy of the present algorithm what Netflix is using. So they're ready to give that much price to get a better algorithm. So you can think of how much business they are going to do once they have a better algorithm with them, which can recommend people better, so that people will not cancel their subscription, and at the end the company will get the benefit. Okay, so so let me discuss another example here. So we know about Rolls-Royce. That's the manufacturing, the enormous engines they manufacture. Yeah. So while manufacturing the engine, they do use a lot of AI techniques, the AI processes and all. But at the end, they came up with a better scheme, so which is called the total care. So uh, that that so that scheme is called total care. What is total care here? So you come and buy the engine from us. Okay, you did not pay the price of the engine. You take the engine and use it. The company will take the money per hour, how many hours the engine ran. Accordingly, they have to pay to Rolls-Royce. I hope I made it clear to all of you. So basically, so they will take care of all the maintenance of the engine. Again, you may think that how sitting in somewhere, how will they maintain the engine? Maybe the engine is used in an aircraft. Yes. So they have used many IoT devices. They have used cameras. Okay. So using that, they take data continuously about those engines, and they do a predictive maintenance. So being a customer, you are free of that the problem, in the sense that you don't have to do unlike the when you buy a car. So we buy the car, and the maintenance is ours, isn't it? So but here you don't buy the engine. The company will charge you the number of hours you have used the engine. So not only, and also using all AI techniques, AI ML techniques, they will maintain those engines for the customer, and they will charge accordingly. And so you can see that this is a new business model. Okay, and this is a very real source of the company. And the company, the contract will be for longer time. So the business will be also for longer time. Okay, so using AI, not only you could manufacture better engines, better product, but also it showed you another way of business. So this is what we learned from this Rolls-Royce example. Okay, so notice that at the beginning we talked about the security domain, and then we talked about healthcare domain, Then we talked about finance. Okay, then we talked about entertainment domain. Now you are talking about manufacturing. Okay, so did you see the use of AI across domains? So let me take you through the last example for today's session, and that is Amazon Go. I'm sure all of you know about Amazon Go. So just let me tell you a little bit about this technology. So this is called Just Go technology. In the sense, you know, so there will be stores, Amazon Go stores. You get into the store, do the shopping what you want, okay, and then just come out. You know, whatever you have purchased, the amount will automatically be deducted from your account. At the beginning, while getting into the store, you will be, you know, swapping in, you will be your account information will, they'll be taking your account information, and accordingly what you shop, the money will be deducted automatically from your account. So then how does it help? So with this, you don't have to go and stand in a queue for billing. So can you just relate this? So we go to you know, malls, supermarkets, big supermarkets, and we see a lot of things. There will be sale, like, right? There will be so many things in less price. We tend to buy a lot, so our shopping cart will be filled. And at the end, we have to check in, right? We have to do the billing. And when we reach billing, we will see that many people like us have you know, shopped many things, filling, and there is a huge queue, and then we get disappointed. So you will not have patience to stand in the queue and finish the billing process, right? And with this technology, what will happen? Amazon Go. So you go, do all kinds of shopping, and just go. There is no need to stand in the queue for billing. Billing will be done automatically, and the money will also get deducted from your account automatically. So that's an amazing technology. Okay, so in India there is no Amazon Go stores till now, but in US there are many such stores. Um, so I just wanted to summarize what we discussed till now. So see, using AI, we not only we solved very sophisticated problems like, you know, uh, stopping the fraudulent transactions, or, you know, helping a patient. These are very sophisticated work, like sophisticated things. And also we talked about the recommendations, the, you know, the engine, you know, such an important thing. So not only we solved all those important things, but also using AI, we got solution to a very, you know, day-to-day life problem. So shopping is just every day we do, right? We go to a shop and do shopping, and yeah. So so that's what I want to emphasize here, that not only AI is used to solve very serious problems, sophisticated problems, but they are also used in solving our day-to-day life problems. So such a technology is this AI. Okay, so I can just conclude what we discussed till now. So adoption of AI is leading to creation of new business lines. This is what we saw in the Rolls-Royce example. Competitive advantage, like you know, Netflix. So if you have better recommendation systems, you will be the winner, right? Like cost reduction, increased productivity, process improvements, personalized communication at scale. Also, it leads to AI centered innovations of products and processes. So all these things we can see we are achieving using AI and AI related technologies. So this is, and also the you know, according to McKinsey, AI is estimated to create an additional 13 trillion US dollars of value annually by the end of 2030. Okay, so this is a big number. And also we you know, while discussing all those applications, we saw that across domains, may be travel, logistics, automotive, oil and gas, agriculture. So everywhere we saw the usage of, or the application of AI. Okay, so I hope all of you know who is Andrew Ng. So he is a famous figure. You know, he's a like research and all. He's also Coursera. He is an adjunct professor at Stanford University right now. So according to Andrew Ng, AI is the new electricity, and irrespective of the industry, so AI will bring value, will bring business to that industry. We only have to look at what kind of problems we can solve in that particular domain. So correctly, he has told that AI is the new electricity to our society. So irrespective of any domain, it will find its application. Okay. So this motivates to talk to adopt AI. So after that, let us get into the second section of my presentation. That is, what is AI? So what is AI? So according to Marvin Minsky, so he is one father figure in AI. So according to him, AI is the science of making machines do things that would require intelligence if done by men. And because the machines will be doing things and machines are having intelligence, and that is not real intelligence, that is artificial intelligence. So maybe that is how he has defined artificial intelligence. Okay, so machines can do things which will require intelligence if a human being does it. So correctly, he has brought the concept of artificial intelligence here. Okay, so we can see two types of artificial intelligence here. One is artificial narrow intelligence, and the other is artificial general intelligence. When we talk about artificial narrow intelligence, it is like working on a particular part of the brain, in the sense that one particular work is getting done if you apply this kind of intelligence, narrow intelligence, or weak intelligence also, you can say. For example, if you say Siri or self-driving cars, they're good at doing one kind of task. They cannot do all the tasks like a human being. A human being can drive, he can think of, he can solve problems, a lot of things human being can do, human intelligence. But if I talk about narrow intelligence, it is good at solving one kind of problem at a time. And when we talk about general intelligence, it is like the machines that have that exhibit human intelligence and can perform anything that humans do. So that kind of intelligence is called artificial general intelligence. And we are way to achieve this kind of intelligence. Till now, maybe we are yet to reach this part. But yes, as far as narrow intelligence is concerned, we have many devices, many machines, many applications where we see such kind of intelligence. Okay, so yes, we are, of course, trying to achieve this also, using neural networks, like neural, like human, how the brain works. So like that, we want to create machines which can work like that. And yeah, so maybe sooner or later, we will also, desire to achieve this general intelligence. Okay. So now let us talk about various aspects of intelligence, artificial intelligence. So when we talk about human intelligence, there are various aspects, isn't it? So if you see the vision, right? Eye is a very important aspect. So isn't it? So can you think of that? Like that really, so it helps in solving problems, through vision, right? So similarly, speech, our language, right? So these are various aspects of human intelligence. Similarly, when we talk about artificial intelligence, there are various aspects like vision, machine learning, natural language processing, planning, right? Expert system, robotics. So these are very important aspects of artificial intelligence. Okay, so I see many people like yeah, I don't know about you, but I have seen people like they will not distinguish about what is machine learning, then what is AI. Is a part of machine learning, or machine learning is a part of AI? Okay, so a lot of confusions people have, but from this slide you can understand that AI is a big umbrella. Okay, and it has various aspects. All these techniques will help in achieving the intelligence. Okay, and if I see 5 years or maybe 6 years down the line back, I'll see that this machine learning and NLP. Okay, so I can see that machine learning and this NLP were very much into the market, right? So industry was really like using machine learning and NLP. But if I see right now how the industry has taken shape is around vision and speech. Okay, so yeah, so because if you see these days, it is very easy to take data as an image. So that's how image analytics or computer vision has become an important important technique in industries. So solving problems, many projects you will see that they're around computer vision or speech recognition or natural language processing. Okay, so that this talk, I want to give little more stress on machine learning and natural language processing. But yes, computer vision and speech. So these are also very important aspects, and you need to see what all techniques, what technologies are there to solve various tasks in computer vision and related to speech. Okay, so yeah, so let us machine learning a little. So machine learning is all about prediction. Okay, so let us see, so what kind of problems we can solve using machine learning. So the problems like, will an aircraft engine component function normally or fail in the next 200 hours based on the performance data obtained from the sensors? Questions like this. Will it, is there maintenance required in coming 50 hours? Or how much loan has to be sanctioned to a company so that the company will repay the loan back to the bank? Questions like that. Or what are the chances that a patient who is admitted in ICU will survive, given all medical test parameters? All such problems can be solved using AI techniques. Okay, so all such problems can be used using machine learning techniques. Okay, so let me just tell you how machine make predictions. So if you know algorithms, it's fine, but for a beginner, it looks very unintuitive. Like, how can a machine predict future based on the historical data? Right. So let us look into that a little. So when we talk about machine learning, so main thing is data. All the learning has to happen on data. So data is the main thing here, right? Data is the hero here. So yeah. So but the data can be any form, isn't it? So data can be very different. Data can be in an Excel file, data can be an image, data can be text, right? So data can be in any format. So that's why, depending on the nature of data, the learnings are different. Okay, so basically, broadly, we say that supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. So these are few types of learning, depends on the type of data we are dealing with. Okay, so when we talk about supervised learning, so in the data set, we see input variables as well as output variables. For example, when we predict the price of a house in a given location, the input variables or the independent variables will be like square feet, bedrooms, number of bedrooms, what is the location, who is the builder, and price, which is the output variable. Similarly, when we talk about spam, right? So spam classification, the emails will be the input, the body, the text in the email. And whether the email is a spam or not a spam is the output variable. Okay, so when we see these two things together in a data set, input variable and the output variable, of course, depending on the problem we are talking about, those kind of data sets will qualify for supervised learning. Okay, for example, suppose the cars, predicting the car price. Okay, so maybe what is the brand, what is the model, what is the registration year, how many miles the car has already driven, and accordingly the car. So if you see this brand, car model, Okay, so all these are input variables, and price is the output variable, dependent variable. Price is dependent on the other variables. So such a data set will qualify for supervised learning. Okay, so if we talk about supervised learning, we mostly talk about two techniques, classification and regression. Both are predictive in nature. When we talk about classification, classification predicts discrete values, while regression predicts continuous values. For example, in discrete problems, we can say that whether a mail is spam or not, yes or no, whether a patient is diabetic or not, yes or no. So those are discrete variables. And when we talk about regression, if you want to predict the quarterly result of a company, coming quarter of a company, so that is a continuous variable. So in that case, the prediction will be continuous, and the technique will be called as regression. Okay, so these are two different types of problem, and yeah, so that is what I discussed. So classification is about predicting discrete values, and regression is all about predicting a continuous value. Like suppose in a bank, a customer has applied for some loan, and the bank has to decide whether the loan has to be sanctioned or not. So here the output is a discrete variable. So this kind of problem will go under classification problems. And when you want how much loan, what loan amount has to be sanctioned, so that's a continuous variable. So that kind of problem will go under regression. Okay, so here we find a relation between variables, maybe a linear, sometimes it is a linear equation, sometimes it is a polynomial equation. So accordingly, we use regression. Okay, similarly for classification. Okay, so we have different kinds of algorithms, many different algorithms we use for classification, like support vector machine, decision trees, k nearest neighbor, logistic regression, naive Bayes, right? So many such algorithms are there for classification. You may ask why so many different algorithms, right? So these, you will see that the nature, the way the algorithms are designed are very different from each other. And the answer is, you need many different algorithms for classification because you do not know what kind of data you're dealing with. Okay, and you do not know the separability of the data, the classes, the classification, the classes in the classification, how different they are, whether they are, means what kind of separability you have in your data set. It is not known. So you may try different algorithms, and you can see what is the accuracy of all these algorithms or these models. And accordingly, you choose the best algorithm. Okay, so when we talk about support vector machine, this is separation-based technique. Decision trees, this is a tree-based technique. K nearest neighbor, this is a similarity-based technique. Logistic regression, this is a soft classifier. It doesn't classify the instances directly, but it gives a probability that, what is the probability that a given instance belongs to a class. So those kind of answers, those kind of probabilistic answers can be, so this logistic regression gives those kind of answers. Okay, so here just an illustration how support vector machine is a distance based classification. And here if you see decision tree, so depending on various rules, how you come up with a tree, and you use this tree as a model, right? Similarly, when we talk about k nearest neighbors, we talk about the similarity. So given an instance, how similar it is to its neighbors. Okay, and accordingly we classify that particular instance, particular data point. Similarly, logistic regression, though you see regression over here, but this is a classification technique, but this is a soft classifier in the sense that it gives probability of an instance being in a class. Okay, so this is how logistic regression works. So when you go into that detail, you will see that you use a sigmoid curve as a model in this technique. Okay, so another very important machine learning technique is so class of problems you can say that is deep learning. And deep learning, when we talk about deep learning, we talk about an artificial neural network. Yeah, so we have seen many other algorithms right now, but later what the researchers thought about is, can we come up with a machine or can we come up with an algorithm which works the way a human brain works? And there is the birth of artificial neural networks. So if you see human brain, so the basic processing unit is the neuron. So a lot of neurons are there in a brain, in a human brain, and they're connected through a network, not wire connection, but through chemicals, of course. They're connected as a network, and this network is responsible for our intelligence and other things. So can you come up with such a algorithm or such a framework which decides or which learns the way a human brain learns? And that is what is an artificial neural network. And when we solve very complicated problems, there will be many layers, many hidden layers in this network. And then this network will be called as a deep artificial neural network. And the learning happens in a deep artificial neural network is deep learning. So if you see the trend of the current trend, that is deep learning. Okay, so you can see that, so there will be an input layer, there is a processing layer, that's called a hidden layer, and then there is a output layer. Okay, so here, so for example, if you have the car model, if you have the age of the car, if you have the miles driven, so if once you give the input, so, so the connections, the weights will be learned. So accordingly, the way you have defined your network, and accordingly, you will get output. If the network will learn, and then when you talk about a new car and you want to know its price, you just feed the input to this network. It will tell you what can be the selling price of the car. Okay, so this is how the deep learning works. Similarly, classifying the images and all, you can use neural networks. There are different types of neural networks, but from industry perspective, I can see that CNN and RNN are used to a great extent. CNNs are very good for image kind of a task, image related tasks like in computer vision. And if you see recurrent neural network, so they are good at speech, language related tasks. Okay, so other things are also there, like new, if you see that GANs and then autoencoders, so other things are there, but we see usage of these two kinds of network, two kinds of artificial neural network a lot in industry. Similarly, so those were unsupervised learning, supervised learning we were talking about, and there is another kind of learning called unsupervised learning. So here, output, the dependent variable is not present in your data set. So, so different kind of algorithms are there to handle such data set. Okay, so basically we can find different patterns, some data exploration can be done on those kind of data, and we talk about association analysis or clustering. Those kind of techniques are used in unsupervised learning, when in the data there is no dependent variable or there is no output variable present in the data. So we talk about different techniques. All supervised techniques we cannot apply here. So here the techniques are like clustering, association mining. Some neural networks are also unsupervised. Okay, so there are other techniques also. Yeah. So another kind of learning is reinforcement learning. So this is a promising, so it has a lot of promise, but in industry, we don't see a lot of application of reinforcement learning. So reinforcement learning is basically, it is not explicitly told on how to perform the task. It learns by experience or reward-based learning. Okay, so it has a lot of promise, but as far as industry is concerned, we don't see a lot of application of reinforcement learning. Definitely in other things like games and all, it has a lot of use. But yeah, so maybe sooner or later we will see this kind of learning also coming up in industry. Another kind of technique is natural language processing. So you might have seen in this pandemic period how these bots were helpful, right? So whatever query we have, so are answered by bots like a human. So the question is, can machines understand knowledge available in human language? Or can machines communicate with humans in their language? Yes, and the technique is natural language processing. And so if you talk about Siri or Alexa, right? So they are able to understand what you are telling. Not only they are able to understand, but they can also act accordingly. When you would tell Alexa, order a pizza for me, Alexa will know, will understand. It will look for the pizza vendors who are available in your system, and accordingly, it can do its job. Yeah, so that is another promising area I can see, natural language processing. Okay, so these are few examples from NLP. So let us talk about AI in practice. Okay, so let us talk about the architecture and how do we go about implementing these algorithms in real life. Okay, so first we have the historical data available. Without data, there is no learning, right? So first we need to have the historical data, and historical data as such cannot be used for analysis or or predicting or so. First it has to go under feature engineering or cleaning, the second stage, I would say. So that is called the data cleaning process. So there lot of churning and all it will go through. So so some noise will be there in the data, some features, lot of things will be there which may not be needed for the for the algorithm to predict. So all those things you need to take care in this stage, at the first stage, right? That's called feature engineering, data cleaning. And then you divide the data into yeah, so depending on the data you can decide, so maybe 80-20 or 75-25, in that ratio you want to partition the data so that you can build model on one piece and the built model can be validated on the other piece. Okay, so that's how on the training data, which is a little bigger piece because the training needs a little more data. So on the training data we build ML algorithms, and then that model will be, this test data will be passed in that model. Then we will see what is the accuracy of the model, whether the model is good or not. Okay, so once we are satisfied, once we validate our model and we are happy with the performance, we can deploy it. Deploy it in the sense that new data can come in and the model can predict it for us. So this is how the process, the process works. Okay, and then yeah, this is for example, yeah, so maybe in an insurance company, 5 people to detect insurance claims manually. The suspect claims are then sent to a team of inspectors to physically verify them. The insurance company feels that the process is slow and costly, right? So in insurance domain you will see that it has a lot of applications. Okay, so but if you have a process like this, AI ML process, so you will see that things are faster and more accurate. Okay, so you have data about many such incidents, and then you clean the data, train the data, maybe so, and then build the model. Maybe it can be predictive or it can be some clustering, right? And then validate the model, and then you can deploy. Okay, so yeah, similarly other things are there. So similarly when I talk about AI architecture, so this is also same, but here it may so happen that your data is big, right? So first you collect the data can come through various sources. Okay, first you need to manage the data, information management. Okay, so maybe you can talk about various databases or the parallel distribution, right? The Hadoop kind of structure you can talk about here, in which you can store the data. And on this data, you can apply various AI technologies, build a model, validate the model, and then deploy the model, maybe in apps or in web or in bots. So wherever you want, that curated model can be deployed. So this is how the AI architecture looks, step by step. Okay. Okay, so let me see how much time I have. I have some 10 to 15 minutes time. So I will talk about how AI has transformed business, various different domains in various domains. Okay, so first let us talk about So let us talk about the applications of AI first in various domain. So let us talk about retail first. So in retail, if you talk about AI, yes, AI has played a very important role in retail. Okay, so we can talk about conversational commerce, contextual commerce, actionable analytics, predictive marketing, right, guided sales, and all these companies have implemented them, uh, and got the advantage, right? Conversational commerce. What is that? So this is about the bot. You can talk to the bots, and they can answer your queries, and as accurate as possible. Okay, so you do not need many people to talk to and all. Okay, similarly, contextual commerce. Contextual commerce is like suppose you are seeing some online content, okay, and you liked something, and then and there you buy that, then and there you do the transaction. Okay, so what will happen is you don't have to go to another site to change things and all. Then and there you can do the transaction. That's contextual commerce. Okay, so similarly, actionable analytics, predictive marketing, right? So depending on various things, various occasions and all, the algorithms, the models can predict what can be the requirement, what kind of requirement you have. So accordingly, the manufacturers will manufacture the product, and the business can be done. Okay, so similarly, guided sales, all these things are there. And in healthcare, so AI has tremendous potential in healthcare. So starting from automated image diagnosis to robot assisted surgeries, virtual nursing assistants, fraud detection, diagnosis, and administrative workflow flow assistant. Right, all these things. In all these things, you can use AI to get the problems solved. Okay, and all these companies, all these hospitals, I can say, are using these technologies and getting uh, the benefit. Okay, so in healthcare domain, there is a lot of potential. Also, I can talk about AI and banking. So again, you have seen in this domain, it has a lot of application, right? Starting from risk assessment to investment management, trading, credit approval, customer support. So all these things, AI technologies can be used, and difficult problems can be solved. So, and all these, if you see Bank of America and HDFC, so many such banks or finance companies are using these technologies and solving their problems. Okay, so similarly, I can talk about manufacturing. Okay, so manufacturing also, it has lot of promise, like having digital twins, to so before getting the product into the market, you can just simulate the product, right, in a virtually, and then test the performance. So that's the digital twins. Adaptive manufacturing, so all these things can be done using AI. AI in energy. So that is a very interesting field. So we can also see usage of a lot of usage of AI ML techniques in oil and gas industries. So so here we have Shell, and then we also know we have other clients which do reach to us with their problems, and we have proposed AI-based solutions to their problems, starting from drilling the field where oil is present, to carry the oil to the refineries. So in all that process, you can use AI in a better way. Okay. So all those things are there, and so if you see the business benefits, you'll get using AI technologies. You have competitive advantage. You have new business line creation, right? So all these things you can achieve using AI techniques. Okay, so I think we are almost time. So I was told to spend some 45 minutes, but so maybe let us touch upon the last section of this presentation, that is the AI platforms. Okay, So this is very important, AI platforms, because we need to have all the tools and techniques in one place to carry out the implementation, the development, right? So what is AI platform, by the way? AI platforms provide users with tools to build, deploy, and monitor AI algorithms. Okay, so it combines intelligent decision-making algorithms with data and enables the developers to create business solutions. Okay, and also, if you are not a skilled data scientist, so users without intensive data science skills get benefit from platforms, from the AI platforms features. Means you will see that there will be many algorithms, so you just have to drag and drop or select what kind of things you want to do, and it can be done. Okay, and also the tools, the techniques, all the are in one place. So it is very important to talk about AI platforms when we talk about any solution involved AI. Okay. So if you talk about Infosys, Infosys also has an AI platform that's called Infosys Nia. Okay. So we do various kind of so various kinds of tasks are done using this platform, starting from Nia automation to Nia knowledge, Nia chatbot, Nia data, Nia advanced ML. So all these things are there in our platform. Okay, so actually a lot of vision capabilities are also there, but due to the interest of time, maybe we will not be able to discuss much. So let's talk about the platforms offered by other vendors. Okay, so we know about IBM Watson. Okay, so this is, so you can talk about, so it's a leader in predictive analytics and machine learning solutions, according to Forrester Wave in the first quarter of 2017. Okay, so it has many microservices, so tone analyzer, emotion analysis, sentiment analysis. So all those things you can see in this platform. And it offers a knowledge studio, that reads through natural language text, annotates it, and creates knowledge model. Okay, so similarly, you will see that it has a lot of other stuff like data platforms, analytics and ML services. Okay, similarly, another I can talk about is Amazon AI ecosystem. Okay, so it has Amazon Lex, the same conversational engine that that powers Alexa. Okay, so offers scalable infrastructure with configured development environments with deep learning capabilities for developing custom AI applications. So so AWS we also talk about, right? So that is also Amazon Web Service. So that is also another important AI platform. We can talk about Google. So Google has GCP, right? Google Cloud Platform, and so if you talk about Google, so they are really high performance, so algorithms and all you will see in Google, because they use something called TPUs, tensor processing units, which is more powerful than CPU and GPU. Okay, so so you can do a lot of things using TPUs, and I would say that as image is concerned, Google platform maybe will be the number one. Okay, so so it has BigQuery, it has cloud data flow, machine learning, Google Cloud machine learning. So all these ready-made APIs also you will get, so that you don't have to program from scratch. You will have ready-made APIs which you can use. You can just input your data and get the model built and use the model. Okay, so that's so, and also Microsoft, we have Azure. Okay, so that is also very capable. So as far as machine learning capabilities, analytics capabilities are concerned, so that's also stand front, the Microsoft Azure. So with that, I conclude my talk. Thank you very much. So let me summarize what we did in this 1 hour, 45 minutes, sorry. So we started with why AI. Okay, so why there is a need of AI in industries and business today. So that is what we discussed at the beginning. And then we talked about what is AI. And then it was a little technical. We also discussed various important AI techniques, AI ML techniques. And then we talked about how AI is used across domains, across business domains, starting from healthcare to manufacturing to energy, right? So all those things we discussed. And then we talked about AI platforms. So yeah, so that's what we discussed in now this presentation. I hope you are motivated now to take up the subject. And yeah, so market is too big, job opportunities are too high, right? So all the best. And with this, I will conclude my talk. Thank you very much.